Okay, so next topic is Java Programming Basics. So in this presentation, we are going to dissect that Hello World application that we just built in our previous lab in detail, step by step and line by line. So that's the first thing we're going to do. We're going to dissect the Hello World sample application. Then we are going to learn the concept of Java comment, statements and blocks, and Java identifiers, and Java literals, concept of variables, and primitive types and operators. If you have worked with any programming language, and these are pretty basic concepts that are common in all programming languages, so these are not going to be anything new to you. Let's dissect Hello World sample application. So this is the sample application that we have compiled and then run it using command line tools and as well as using an IDE. So let's take a look at each of these line by line in detail. The first, public class hello. As we're going to learn later on, the way you are going to declare a class is using class keyword. Okay, so the name of the class is hello, and class is a keyword. So it's indicating that I'm defining, or actually I'm declaring a hello class. Public is basically indicating this class should be able to be accessible by anybody. Okay, so we're going to talk about this concept of access modifier. In fact, there are multiple access modifiers such as public, private, protected, and things like that. So here we are using public, indicating this class should be able to be used by anybody. And then the class definition start with this the curly brace. So it's indicating the start of the code block. Okay. So I think one of the questions that was asked by Roger, I think, was that I said every Java statement should have the semicolon at the end. So how come this guy doesn't have a semicolon at the end? Okay, so that's an excellent question. So semicolon is needed only for Java statement. Okay, so inside this block, you are going to have a set of Java statements. So those Java statements should have a semicolon at the end. Okay, but this is just starting. This is just indicating this is the start of the code block. Okay, so that's the reason you don't have to have a semicolon at the end, because this is not a Java statement. It's just declaring your class. Okay. By the way, in Java, the spaces are ignored. Okay, so typically if you starting in the code block, you might in fact have a code block, this curly brace at the end of your class declaration here, or you might in fact actually have a next line. It's completely up to you. Okay, so when the bytecode, the class file gets generated, all these spaces are gonna be ignored. Okay, and then we are going to have a comment in this case. So the slash and star and the star slash, everything in between, they are considered as comments, which means they are not considered as Java statement. Okay, so when the bytecode gets generated, these comments are removed. So this is for humans. Okay, comments only for humans to read the Java program and actually understand what it does. So as far as the bytecode is concerned, it's removed. Okay, then we have our first method, and this main is a special method. Okay, so as you're going to learn later on, method is basically where you are going to have your behavior of your class, okay, which includes a set of methods. The set of Java statements. And this main is a special method. It indicates this is the starting point of your application. So when you run the application, the starting entry point is this main. Okay, so when you run your application, Java runtime environment, meaning JRE or java.exe, will search for the main method, and that's where it is. That's where the program gets started. Okay, so main method is a special method which indicates the starting point of your Java program. The main method always take the command line arguments in the form of a string array. Okay, so we're going to actually talk about that in a bit more detail later on. So basically, whatever you specify at the end of your application will be captured as an array of strings. Again, we're going to talk about the concept of array later on in a bit more detail. Okay, and then we have another comment. So there are two ways you can have comments. One is this slash star and the star slash. So this is typically used for multi-line comment. If you want to have a single line comment, then you can use this slash slash. Okay, so again, this is a comment, which means it will be removed when this program gets compiled. Okay, so it's a single line Java comment. And then we have a Java statement. So system.out.println and hello world. So this is the Java statement. So this Java statement should end with a semicolon. Okay. And then your code block, meaning a set of Java statement, will be enclosed with another curly brace, ending curly brace, and your class also should end with a curly brace. Okay. Okay, so coding requirement. The file name and class name must match. So in our case, when you create the hello.java file, inside it should have a hello class. So if you actually have hello with the, if you say hello1, but you have this hello1 class inside the hello.java file, then it is a compile error. So the name of the class always has to match the name of the file. Okay, so that is a requirement. Otherwise, it's a compiler error. Okay. Okay, so Java comment. So we have seen two types of Java comments, right? So single line comment is preceded with slash slash. Multi-line comments start with slash star and star slash. Okay, statements and blocks. So Java statement is terminated by semicolon, as we talked about. Okay, so Java statement is the one that actually provides some kind of logic. So here we are displaying hello world. Here we are assigning value 2 to a variable called the x. So each of these are considered as a Java statement. Code block, as we talked about, code block is a collection of Java statement, and the code block should begin with a curly brace and end with a curly brace. Okay, and as we talked about, the white spaces are ignored. Okay, so you could in fact have these two lines in a single line. So here we have these two lines in a separate line, but syntax wise you can have this one right here as well. Okay, but in general you want to have a single statement in a single physical line. Okay, so that is a code block. Code block is a collection of Java statements. Okay, moving forward. Java identifiers. Java identifiers are basically, you can think of it as a name. Name of variable, name of method, name of a class. So we are going to talk about the concept of variable, method, and class later on. Each of these things should have a name. Okay, so those are called Java identifiers. So in our case, hello is the name of the class, right? So that is Java identifier. Main is the name of the method. System is the name of the class, and out is the name of a field. Okay, so all these guys are in fact names that you can actually provide, and they should actually follow certain set of rules. Okay, meaning, so let me actually talk about that rule here first. It should start with a letter, or underscore, or dollar sign. Okay, so you cannot start your name as a number. However, the numbers can appear right after the letter. Okay, so the names has to be following these rules. So you cannot have like a 3 hello as a class name. That's a compiler error. Okay, but you can say hello 2. That is perfectly legal, the class name. Okay, so Java identifiers, meaning these names are case sensitive, meaning this capital H hello is not the same as the small h hello. So they are considered to be completely two different names. Okay. And of course, your names, meaning the identifier, meaning names of the variable, names of the methods, and names of the class, cannot use Java keyword. So Java comes with a set of keywords. So these are pre-reserved names in a sense. So you cannot use them as as a name of your class or name of your method or name of your variable. Like a class, public, void. These are keywords. Right? So Java keywords are predefined identifiers reserved by Java for specific purpose. So you cannot use these keywords as your own identifiers. Okay, so otherwise it's going to be a compile error. Okay, so this slide shows a subset of Java keywords. So these are the keywords of the old JDK 1.3 or 1.4, something like that. Okay, the later versions also have a few more keywords. Okay, so these keywords are not, they are not supposed to be, you cannot use these keywords as the name of the class, name of the method, and name of your variable. Kind of makes sense, right? Okay, concept of Java literal. So literal you can think of as a constant value. Okay, so there are different types of literals allowed in Java: integer literals, floating point literals, Boolean literals, character literals, and string literals. So let's take a look at examples of this. So these are examples of integer literal. It could be decimal, it could be hexadecimal, it could be octal. Typically you're going to use a decimal, so like a 12 or 13, 200 or something like that. Floating point, so represent decimals with a fractional part, like a 3.1.4, 3.xxx, something like that, or 583.45 or 5, something like that. So these floating point is typically used for the scientific computation. Boolean could be either true or false. Okay, so these true and false, those are keywords. So you cannot use this true or false as name of your variable or name of your method. Character literal represent a particular Unicode character. Okay, so character literal will be represented by a single code. So if you want to have A as character literal, then you say single quote A. There are special characters as well. So if you say /n, that represents a new character. So new line character. /r represent character carriage return. /b represent backspace. So you could use these things as in your Java program if you want to. Okay. String, we're going to actually learn string literals in a bit more detail. So string literals represent multiple characters. So string literals should start with a double quote and end with a double quote. Okay, so hello world, this is a string literal. Okay, moving forward, the concept of variables. So variables are used to store the state of object instances. So we haven't talked about the concept of class and object. Okay, but for now you can think of object is a single instance of a class, and each of those objects should have different value in its variables. So you can think of variables is like a properties. Okay. So variable has a data type and the name. So let me show the example of variable. So suppose if I want to declare a variable called the grade, I have to specify the type of it, like a double. This is the primitive type double, and then I can also even assign the value to it. So here I have a variable called the grade, whose type is primitive double, and the value of 0.0 is assigned to it. Here I'm declaring so-called reference type or object type or wrapper type, the double type, and the name of the variable is grade 2. And here I'm declaring a person type, and the name of the variable is x. So the key point is that every variable should have a type. So Java is actually considered what is called a static type language as opposed to dynamic type language, because everything has a type in Java. Okay. Okay, so this is the somewhat complete program. So we have declared a class called the variable samples. Then we have a special method called the main. Every Java program should have this special method called main. Public static void main, and a set of arguments like this. Then you have a code block. So the code block, every method should have a code block, and this special main method has its own code block. So code block start with this curly brace and ends with a curly brace. So we have now have how many statements? 1, 2, 3, 4 statement, and we have a bunch of comments. Okay, so this is the declaration of a variable called the result, and nothing is initialized. Okay, here we are declaring an option character variable, and here we are assigning a C character to that variable, and here we are assigning 0.02 double the grade. Okay. If you want to output the value of a variable, then you can use system.out.println statement. So that's something that we have used already. So here, basically I have a variable called the value. It's assigned with the value 10. Then you have a char variable called x, and we assigned a character to it. So if you say system.out.println and then you specify the variable, name of the variable, it will display the value of that variable. In this case is 10. It will display 10 like this. Okay. Here we are displaying, this is the string literal. So we want to display this one first, and then plus this value of x. So a value of x is a, right? So the output is going to be the value of x equal a, because the value of x is in fact a. That's what we set here, right? Okay, so there are two different versions of printing things out. Println is for the printing a new line at the end. So you type, it will print something, then it will add a new line. Okay, print, it doesn't append a new line at the end. So in this case, if you want to use a print method, but if you want to provide a new line yourself, then you can actually add at the end \n character. Okay, so something you can try in the hands-on lab. Okay, so that is exercise 1. So again, the first thing you want to do is to download the hands-on lab file. So here you're going to click the lab and unzip the file. So I have that already. So I'm gonna go to L. So the one that is programming basics. So 1002 zip file. So I'm gonna use the jar command to unzip it. Okay, so now we are going to open the lab documentation. So program basics and index.html file. So this is a lab documentation. So we are doing exercise 1. Okay, so here we are going to create a brand new project. Okay, so again, I'm going to actually demonstrate using Eclipse IDE. So let me just move up here. Oops. Okay, so I am going to create, so here I'm going to create new project, Java project, and the project name, I'm going to just follow the instruction. You can use any name of your choice. My output variable project, so I'm going to just use that one as the name of the project. Okay, and I'm going to use the default location. Okay, or I could use my project, my Java project. If you're actually specifying your own location, you always has to provide the project name at the end, because otherwise you're gonna actually have cluttered things inside the my Java project directory. So you always want to provide the name of the project at the end. okay? Because so the meta information of your project is going to be captured in the project directory rather than the parent directory, okay? And then finish, okay? All right, so now we are going to create so we did this. We are going to create output variable class. Okay, so I'm gonna just create a new class. So on the SRC source, right click, new, and class, and name of the class is this guy, output variable. I don't need a space at the end. Okay, I'm gonna just use the default package for now. So click finish. Okay, so it created a public class output variable. So for now, we are going to just play around with the various set of variables. So you can just say int value equal 10 and semicolon like this, and the same thing here, char x, and then we are going to assign with the oops, I hate this. X is now a, then ends with a semicolon. Oops, ends with a semicolon, and then double and grade. Yeah, use a different value like a 33. Oh yeah, so character AX. What's wrong with this? Syntax error. The syntax error is token expected. What's wrong with this? Okay, so I think my next line was wrong. So x equals what's going on here? Let me just copy this guy. Something is not right. So let me actually see what's going on here. Syntax error on token is expected. It looks good to me. Anyway, so I'm gonna just for now comment this out. I'm gonna, so basically, you are going to just the system out println like this, and the value. Oh yeah, the reason is actually I don't have this guy. Yeah, that's why. Sorry about that. I should actually yeah, I should have these things inside the main method. Yeah, that's why. Stupid. Okay, yeah, so now I should have this guy. It's all right. Okay, yeah, so so now if I run this application, it should actually display some values. In this case 10. Okay, all right, so that's basically what you're gonna actually see. I'm gonna let you actually do these things. Okay, and here you can actually run this application using javac and Java. Okay, so I've created this my output variable under my project, right? So I can go to here, my Java project here, and oh, it looks like I created in the different place. So if I can actually find out this guy where it is, properties, my Java projects, my output variable project. Okay, yeah, so that should be there. My output, my Java project. Oh, it's not programs. My Java project. So I can go over here, my Java project, and here we can actually do the same thing, and we can actually compile this guy. Go to SRC, and we can actually the compile using Java C and things like that. It's just a way of actually the how IDE and command line tools kind of match each other. Okay, so nothing really fancy on the exercise 1.2. Okay, so I'm gonna let you do exercise 1. So if you can, try to type these things as much as possible. Not actually you don't have to type the comment, but at least you want to actually type these things, to get the sense of how the variable definition and how you can use a system out.println the command to display the values of these variables. Okay, so I'm going to give you guys about 5 to 10 minutes to do this exercise 1. Primitive type. So Java programming language define 8 primitive data type: a boolean for logical information, char, byte, short, int, long, and double and float. So primitive data types are not object type. So they are not non-reference data type. So when you say object, we say reference type as well. So object type is the same thing as reference type. Primitive data types are non-object type or non-reference type for that matter. So the reason we have a primitive data types in Java is because they are used for higher performance computation. So it's actually useful to have these primitive data types for performing computation. So other programming languages might not have in fact the primitive types. So in Java, we have a primitive data types and we have object types. So it's kind of hybrid in that sense. So Boolean, basically Boolean data type represent 2 values, true or false. The char is again having the char is represented by single quote. This is the special character of tab, \t, \n is the new line character, and \l is the carriage return and things like that, right? Okay. If you want to represent single quote or double quote as part of the character, then you can say you can specify the escape character. So you can have another \. This represent I want to represent this single quote character. If I want to represent this double quote character, then I'm going to proceed with \escape. The byte, short, int, and long. So basically these are data types that are used to capture values: decimal, octal, and hexadecimal. So this is the decimal value, this is the octal value, and this is for hex values. For long value, you're going to end with L, capital L here, 10L, that represent long value. In terms of its size, a byte is 8 bits, and the short is 16 bits, and int is 32 bits, and long is 64 bits. So range of values are going to be different depending on the type. Floating point, so you can use the notation 3.14, or you can use this E notation, F notation, and things like that. Again, these are used for scientific computation. In terms of the size, so floating point is 32-bit and the double is 64-bit, and you can see the range values, and double is pretty big, power of 308. Okay, so exercise 2. Now we are going to write a very simple program for computing an average and computing sum of some the numeric values. Okay, so let's take a look at the lab documentation. Just read it again. So exercise 2. So here what we want to do is we want to create a brand new project called myAverageNumber project, and inside main method we are going to declare 3 numbers, number 1, number 2, and number 3. And then we are going to perform the average computation. So we are going to add these 3 numbers and then divide by 3. So that will give us average value. And then we display those 3 values. Okay, so when you run it, then it should actually display this. Okay, sum is pretty much the same thing. So sum, here we just compute sum value rather than average. Right? Okay, so pretty straightforward. I'm gonna just continue the presentation of the operators, and then we'll have 20 minutes lunch time and the lab time as well. Operators. So Java provides different types of operators like arithmetic operators, relational operators, logical operators, and conditional operators. Again, these operators are available in other programming languages, so nothing really unique in Java for that matter. So for addition, this is the multiplication, this is the division, this is the compute the remainder of dividing opt by opt2. So if you say 5 %, 2, then remainder is 1. Okay, so result is going to be 1. This is subtraction, of course. Increment and decrement operators. So Java provides what is called the unary increment operator and the unary decrement operator. Okay, so basically it increment by 1 and it decrement by 1. So this is the same thing as this. So here we are adding 1 to count, and then we assign the new value to this count variable, right? So this is a little bit verbose. So this could be represented with count plus plus. So this is the same thing as this guy. Okay, and if you have a minus and then count minus minus is actually the same thing. Now you can actually have this unary operator before the variable and after the variable, and they actually do 2 different things. Okay, so if plus plus is used before the operand, then what it does is it's going to perform the incrementation first before performing computation. Okay, so let's take a look at this example. So in this case, we have set the value of I to 10, value of j is 3, value of k is 0. Now we have this computation. So we have plus plus j and plus I. Now because plus plus unary operator is before j, this j will be incremented first before it's used for computation. So j becomes 4, and then I is 10, right? So now the result of k is going to be 14, right? Now, if you have this plus plus unary operator after j operand, then this incrementation will be performed after computation. So j still stay 3, and j plus I will be performed. So k is going to be 13, and then j will be incremented by 1. So j becomes 4, but the value of k is going to be either 13 or 14 depending on where you have this unary operator. This is relational operators, so greater than equal, less than equal, and the opt1 and opt2 are equal, and this is not equal. Okay, now this greater than and less than are probably reasonably understandable. However, these 2 guys, so for now, for primitive type, it actually comparing the values. Okay, so if 3 equal 3, that should actually return true. If 3 and not equal to 4, that should return true as well. Okay, yeah, so as long as you're using these relational operators with a primitive data type, things are pretty straightforward. If you're using the equal with object, then it has some implication. That's something we're going to actually talk about in a bit more detail moving forward. These are logical operators. So dollar, dollar, and dollar, or the two vertical bar and a single vertical bar. And this is the Boolean logical exclusive OR and logical NOT. So let's take a look at an example of this. Yeah, so this is the case where we have the x1, x2, both of them should be true, and otherwise it's all false. Okay. The vertical bar is the same deal, and this is the it has to be the different value to make it true. So true, false, then returns true. False, true, or returns true. But if they are the same, false, false, and true, true, it should return false. The exclamation mark is logical NOT. Okay. All right. One last one, conditional operator. In this case, this notation is basically expression 1 will be evaluated first, and if it's true, then expression 2 will be evaluated and that will be returned. If expression 1 turns out to be false, then expression 3 will be evaluated and that will be returned. Okay, so let's see an example of this. So here what we want to do is, so this is the example here. So we are going to check whether grade is greater than or equal to 60. Okay, in this case that's true. Grade is set to 80, so that should be true, right? So it should return the value, the first value, which is the pass. That's a string value and we assign to status. If it is false, then the fail string will be returned and assigned to status variable. Okay, so this is what is called the conditional operator. So this will be evaluated first, and if it turns out to be true, this will be evaluated. In this case, just string literal, so that will be returned. If it is false, then the second after the colon will be returned. So that's basically this logic. Okay. Operator precedence. Given a complicated this expression, basically this will be done first, and then this will be done next, and then this will be done first. So multiplication and division is done first before plus and subtraction and addition. So that's pretty much what we do see in other programming languages as well. So this is the same thing as this. Okay, so that is exercise 3 and 4. So let's take a look at the exercise 3 and 4. Okay, so here we are doing that conditional operator. So that's exactly the same code that you have seen in the slide. Okay, so it should display passed. Okay, now you want to do your own exercise. Okay, so what you want to do is set the salary of in this case 10,000, and then if salary is greater than 50,000, you want to display rich, you're rich. Otherwise, you want to display you're poor, something like that. Okay. Find the greatest number. So here we have the 3 numbers, and we have a max. Okay, so we want to compare these 3 numbers to find the max value. So because we have only 3 numbers, things are pretty straightforward. So we're going to compare these 2 values first, and then we are going to compare this the remaining number with the max value. So we get the max value using this conditional operator, and then we're going to actually do another conditional operator. In this case, we are comparing max with the number 3, and we display all the numbers, and then we display the max. It's pretty straightforward. Okay, so that is the end of the hands-on lab. In fact, if you have time, feel free to do this homework as well. Okay. All right, so I'm gonna just stop the presentation.